Welcome to our webinar on the best practices for migrating from on-premise data warehouses to the cloud. My name is Jason and I will be co-hosting today's webinar. Before we jump into a couple of things, a few administrative items. So firstly, feel free to submit any questions during the presentation. I'll be keeping track of these for the Q&A session towards the end. Also, just so you know, we're recording this webinar and it will be made available for you guys tomorrow with the slides. All right, so let's get started. Today you're going to hear from Yair Weinberger, our co-founder and CTO. He's been with Luma for the last 3 years and has been involved with data pipelines for the last 15. So for today's topic, Yair will discuss the benefits of moving to the cloud, then explain the best practices and challenges of migrating from on-premise to the cloud. He will also run through a live demo to show you how we can migrate data from on-premise Oracle Enterprise Data Warehouse to a Snowflake Cloud Data Warehouse. So without further ado, I'll hand it over to Yair to get us started. Yair?
Thank you, Jason. Today I plan to speak about how to move data from on-prem to the cloud and what is the state of data today. Why do we even want to move to the cloud, and then what are the best practices to actually do that? I'm going to demo how Alooma can help actually moving data from on-premise Oracle to Snowflake, and then some best practices from our experience of doing so with our customers. So on-prem only is being harder and harder to maintain, and cloud is definitely on the rise. And maintaining expensive infrastructure, and I'm just going to touch on a few of these, but having huge IT teams just to hold and pet the actual hardware, having separate server room, disaster recovery, the upgrade cycles, how much is it hard to work remotely? All of these are getting more and more companies to move to the cloud, and there are even every new company that's started in the past 5 or even maybe 10 years is already considered born in the cloud, where their infrastructure will just start on the cloud itself. However, for many bigger and older corporations, they are currently on-premise, and most of their infrastructure is being hosted on an on-premise data centers, and they want to enjoy the benefits of the cloud as well. And this research from IDC actually shows the forecast and what's of the share value of the traditional on-premise data center versus the public and private cloud. And as you can see, as of today, we are still with the majority of the data being hosted and being used on an on-premise data centers, and the trend is declining for the past few years. The tipping point is expected to be in 2019, where about 50% will be hosted in public and private cloud, and 50% on traditional data center, and the decline is expected to continue from there. So why are all of these companies moving to the cloud? What benefits are they seeing, and why is on-premise data centers on the decline? And moving to the cloud can significantly reduce the IT cost, both in the upfront cost of purchasing the hardware and placing it in a room with cooling, with networking, with power. The cost of storing data in the cloud today is already comparable to storing it on magnetic disks, and it's much safer in the cloud in the sense of backups and disaster recovery. The environment itself is already fully managed and fully compliant with security requirements, and all of the compliance, like things like PCI and SOC 2 already exist for most of the cloud providers. And maybe the most important thing is it's scalable. As the business scales, it's much easier to scale in the cloud than to put more hardware in the server. And personally, I spent 12 years in the military in the Israel Defense Forces. And for every new project, our biggest problem was that we did not have enough power in the server room. And what we had to think about all the time was the actual PSU, the power supply unit of the server that we were going to buy. And if the power consumption of that specific unit is going to be low enough for us to be able to put it in the server. Of course, in the cloud, none of it matters at all. We just get our hardware provisioned for us, and we can start using it. And as more enterprises are moving to the cloud, the hybrid model is actually becoming more popular because it isn't, and I'm going to talk about it a little bit more at length in the following slides, but it's actually very, very difficult to just do a heart transplant, so to speak, and port everything over immediately to the cloud and just tear down everything we have on premise. So what many companies are doing is they're doing a slow migration that usually takes years or even maybe forever until everything is migrated. But during that time, there is a hybrid strategy where components are being moved to the cloud continuously while we still have to deal with some legacy that exists on premise. So how this plan looks like when we want to migrate to the cloud. Before we even start migrating, before we can even start moving any piece of data, we need to decide on a plan. And the plan usually means what are we going to move? That's the first step. And again, I'm not going to read all of the bullets on this slide, but it starts with what are we going to move? Who is going to be affected? Who are the stakeholders that are going to be affected from the parts that we are going to migrate into the cloud? And then how exactly is that going to happen? Then we can start migrating, and usually our recommendation is to start small and simple. Start with a simple use case that will provide a quick win. Get buy-in from the stakeholders where they can see how their lives are becoming much easier once the data is already in the cloud, and then leverage all of the managed services that the cloud provider already provides, like data warehouse in the cloud and automatic scalability, things like load balancing. Once the migration, and then there is a continuous overhead of maintenance post-migration, where this will be much easier, much cheaper than what we are used to for maintaining and monitoring on-premise infrastructure. But still, this is not some magic where once it's in the cloud, it just runs by itself. It still needs monitoring, it still needs documentation, it still needs all of the tooling around that. So if we look a little bit more detail in how the process looks like, and now I'm actually going to dive into a specific example. We have an on-premise data center, and we have our own applications that are running on this data center. These are using, and for this example, let's talk about an Oracle on-premise database, which is used for a transactional data warehouse for the applications. Many companies choose analytics as the first step they want to move to the cloud, because it's relatively easy in the sense that it does not involve moving any applications. The applications can still run on-premise. The transactional data warehouse remains the same transactional data warehouse. And those applications sometimes are legacy, sometimes the code for this application no longer even exists in the organization. So they remain the same. It's basically, let's take everything we have, let's put super glue on it so that it maintains its current state, but let's move our analytics and let's give access to the data for the entire organization using the cloud technology. So moving analytics is a good first step when migrating into the cloud. And in that use case, we want to take the analytics that's currently run on top of the transactional data warehouse and move it to something like Snowflake, BigQuery, Redshift, which are three of the most popular cloud data warehouses. So the plan is basically three steps. The step one is just let's take a copy of the current data we have in Oracle and put it on the other side. And then let's have an ongoing replication that continuously replicates all of the changes to the cloud. The reason we need ongoing replication is that our application still continues to work with what we have on premise. Again, we don't want a heart transplant scenario where we basically have to switch everything atomically, because it's pretty much impossible when we have thousands of applications on the organization. What we want to do is we want to keep the application working against the Oracle data warehouse, but move the BI and analytics to the other side. So once we have our ongoing application, we can hook up the BI and we can also take the chance to use some new BI tools, maybe use something like Looker or and then train our analysts and our data scientists to use the data on that side. It's not an easy process, and one of the I would say one of the biggest challenges is the sunk cost we already have on existing infrastructure. And I would say that maybe 6 or 7 years ago, almost any enterprise wanted to invest in a Hadoop cluster and build a data lake. And what they find out today is what we found out today, and we see it from many of our customers and the enterprises that we talk to. These existing infrastructures are not providing what they were hoped to provide. So the promise of that was, okay, let's build a data lake, let's put everything in this data lake, and then just it doesn't need to even have a schema. We'll just find out the schema on read when we query the data. And this concept we see breaks, because eventually what we end up is, and I already heard people describe it as a data swamp, where the data is not really accessible. We don't know where each piece of data is because we don't have any schema or any schema repository, and we have no ability to understand how actually to run queries. The number of people that can actually take in a Hadoop error message and understand what's going on under the hood, why did my SQL fail, they are very few, and of course much fewer than the people that we want to give access to the data. But still, this is a challenge because we invested in this millions of dollars cluster, and now we need to basically say, okay, we're going to ditch that and move to a new analytics infrastructure. Then we need to know how to manage the cost of the new infrastructure, which is also not easy. It's not the same. It's a subscription model usually. Sometimes the cost is actually per query and not per for the data warehouse or for the data volume. We need, and maybe the biggest challenge is how do we handle security? Because, and this is even when we start to utilize real-time data, and we start using all of the let's say fancy new technologies like Apache Kafka or Apache Spark. Once we spin up those clusters and start moving our data through them, we lose a lot in security. We lose a lot in data governance. We basically give every developer in the organization that has access to this cluster access to all of our raw and precious data. And then technically, the migration itself is also something that needs to be well thought out. How do we move our data? How do we maintain continuous application? How do we handle data discrepancies? These are the main challenges that we see. And again, I've seen the first usage of this image in the last Google Next conference. But startups are just born in the cloud. They release their application, and that's it. Where in the enterprise journey, we have all of this legacy software that's holding us back, that's currently tied into so many things on premise, where we actually want to move things to the cloud. We found ourselves fighting this huge dragon. And so how Alooma does that, and this is what I want to show next. Alooma is a data pipeline as a service, where it can take data from pretty much any data source and move it to the cloud easily, while taking care of many of the challenges I mentioned about. So taking care, handling the initial migration and the initial transfer of data, handling the continuous replication, and then handling monitoring and security around that process. So again, we could still put what I refer to as super glue around what we currently have working on premise, but just start by moving our analytics to the cloud. And in that example, I already have some data sources set up that are moving into Snowflake. But let's say we want to start fresh. All we do is we click on add a new data source, and that data source you can choose from many of the hundreds of Alooma's integration. In that example, I set up Oracle data warehouse And if I just click on it, it's as simple as just giving Alooma credentials to the Oracle data warehouse, and then choose the appropriate application type and start streaming. Our recommendation is using what we call log replication for every transactional data source, which means instead of, in order to get the data as fresh as possible, instead of just dumping the entire data set and loading it every time, which can be very difficult and resource consuming, just take the transaction log of the database and take those transactions and replicate them into the cloud data warehouse. Alooma can handle, using what we call one-click mode, can handle all of the schema translation and creation on the other side. So we'll take the Oracle schema and we'll just create a matching schema on the data warehouse while translating the appropriate column types. If the data does not have, so for example, for the Oracle example, the data already has a strict schema at the source because it's a database. So it has a table description and column types for each table. Not all data is like that. For example, if you load flat files, their data will just come in and will not have a predefined schema. Alooma will automatically infer the schema from the data and keep up with schema changes in a schema repository. So instead of having to get the schema on read, Alooma enables to actually guess the schema from the data and then ongoing maintain it. Once we added the data source, and I'm going to use what's already been added, it starts streaming immediately. You can actually click on it and see the throughput, even see some sample events that are coming in. So we can see this is which table is the data coming from, which schema, was it an insert, an update, a delete, and the actual field and values. And this is what's going to be transferred eventually. And then we can, of course, modify, add tables, remove tables, etc., from the data source itself. And once it's streaming, it will make its way to the mapper, which is the schema repository I mentioned, which is basically take data from the source, create the same schema on the target, and then continuously move the data over. In that case, we use Snowflake. Snowflake is one of the more popular data warehouses, but of course you can also use Redshift, BigQuery, even Azure SQL. And what's nice about Snowflake is you can actually save nested fields inside a nested field type. So for every nested field like this, you can actually choose: do I want to put it in a flat? Do I want to flatten it, or do I want to put it in a nested field on the target? Again, this is if the target supports nested field types. Both BigQuery and Snowflake support that. For data that does not have a schema, for example, these are flat files that are just coming from Amazon S3. Alooma actually allows, and in that case I left it unmapped on purpose. Alooma allows to automatically identify the data that's coming in. So Alooma will take samples from the data and will automatically guess, okay, this is a number, this is a string, this is supposed to be a timestamp, and according to these, just decide what column it should create on the target data warehouse. Once data is being mapped in streams, and basically we don't need to touch it any longer. However, if we do want to customize or modify our data, we can actually do it using the Alooma code engine. And here we have just some samples of how to split events, how to discard events, how to enrich events. In that example with GeoIP, all of this transformation happen in the Alooma code engine. We can actually get a sample from the live stream and run a test. Of course, none of this needs to actually happen in the browser. It's all API based and can be incorporated into continuous integration processes. What's nice about it is, and if any of the listeners ever had the chance to develop some Informatica ETL processes or using Oracle data integration, is that usually when you want to test, what you're doing is you have some data set that you test your process on before you release it to production. However, usually this data set is stale. and you took some snapshot of the data a long time ago, and that's what is being used to test. And all you have to do, all you have left is to pray that the current data that's streaming is actually the same as the stale data set. With Alooma, the samples are being taken live from the stream. So every test is being conducted on the data that's actually currently streamed. What happens with errors? What happens if something cannot be properly transferred? Because, for example, destination does not match the source. Because, and there could be a million reasons for errors. All of these errors are being caught in the Alooma safety net, or what we call the Restream Queue. These are, and here is an example, which is a number format conversion. We cannot convert a specific value into the target. And then what we can do is, first of all, we have the exact event that created the issue. We have the exact, and again, anyone that built ETL processes knows how frustrating it can be to search for the specific event that created the problem in the pipeline. In that case, this event is being stored, and you can actually see the sample. We can correct it in the code engine. We can fix the mapping. There is a lot we can do just to fix the problem. It's all being caught in the Restream. Once we decided we're ready, we can just click on Restream, and the data will be put back into the pipeline. So no need to reload data, no need to reread the data from the source. Just hit Restream, and the data will be streamed back into the pipeline. Of course, a dashboard to say how many events were loaded, which errors occurred in the pipeline, how many events were received, what's the latency that we get, some controls and monitoring around the data pipeline. Last but not least, the ability to back up all of the data into S3, into Amazon S3. So we can just put S3 credentials, and again, this is our own. Alooma does not store any data. This is in our own Amazon account. Just back up all of the raw data into S3, and then, especially if we have transient events that are coming in from websites or mobile applications that cannot be repeated from the source, if you want to replay them and run a different code engine, run a different calculation, we can always read them back from S3. So just because storage is so cheap, just store all of the raw data. You can also even see how our live stream looks like. So this is data that's currently streaming as we speak. We can see, again, samples of the event. It can be used as a very useful gut check to see which data is currently streaming. We can filter to see only events that are coming from a specific source or from a specific table. And it's usually very, very, very useful for debugging and understanding what's currently going through the pipeline. Some lesson learned from a healthcare company. And then what we recommend is start with a small use case, which is a quick win. Enabling, and one example is just enable data that's currently hidden. Data that's currently inaccessible to most of the company. But with maybe a very small effort, we can move this data into the cloud and open the access to it to company-wide or to all of our analysts. Cost planning is important, especially when the data warehouse is cost per query based. For example, Google BigQuery and Snowflake both the costs are being calculated based on the compute that's being executed. So some queries that we used to do that would scan all of the data set are very expensive now. So two recommendations here. One is to limit resources per project so that we know upfront how much we're going to pay. And again, every cloud data warehouse supports that. But also create a materialized views for data that is frequently joined. And I actually did not show that, but Alooma also has a scheduler that supports scheduling queries to create those materialized views. So if there is a data that's frequently joined, instead of computing the join every time, let's just compute it once every hour, every 2 hours, every 30 minutes, whatever frequency that we need, and then query this materialized view. We need to plan the security model ahead, and especially with healthcare, which is the example that I'm now describing, but we've seen this also with many other industries like financial services. Some data can never leave the on-prem environment because it will break compliance, it will break customer contracts. So we need to plan the security model ahead. Sometimes we need to do some clever tricks to prevent this data from being read by Alooma. Just one example that came up is when reading from MySQL, transaction log is using a black hole storage engine, which is sort of MySQL's dev null, to be able to prevent PII data or PCI protected data to be even read by the Alooma side or by anything that migrates data to cloud. Two things that makes analysts very happy and are very useful for quick win. One is just email to data warehouse, and again with that company, there was a marketing analyst where what he would do every day was to get the emails from all of the distribution channels, which were like a CSV reports, and then combine the data in Excel to create a report for management. Once we were able to just tell him, okay, point those emails to us. Don't bother with downloading them. Don't bother with copy paste them. Don't bother with pivoting them in Excel. Just add an Alooma email address to those reports, and then everything will automatically appear in the data warehouse. Then all of the reports suddenly, instead of a day of copy pasting, became 5 minutes of one SQL query. And the other thing is that legacy system oftentimes has file-based backup. And IBM DB2 is probably the most common one that we see of just take the backups and load them to the cloud is very helpful when porting analytics from those systems over without touching everything, with keeping everything that we have on-prem currently with a super glue, so to speak. So where Alooma shines, and again, moving to the cloud is useful, and you can probably do it by yourself as well. Spend the time and resources required to develop this. The places where Alooma is really helpful from the customer we've seen is, first, we support hundreds of native integrations that already exist. The data can be very, very close to real time. It can be scheduled in batches as well, but when data is needed in real time, it comes in real time. Scalable to pretty much any size, any data size, and secure. And again, this is what we see when we see teams implementing cloud migration themselves. The first thing we see them let go is security. Once they set up those open source tools and give developers access to them. With Alooma, security is already baked into the platform as a very basic part of the package. In closing, I would just say that, and again, you can read this, if you have not yet moved to the cloud, it's the time to do so. And again, start small, build momentum inside your organization, and Alooma can help you with being the data pipeline itself.
Thanks so much, Yair. So hello, everyone, again. If you haven't already done so, please send us your questions in the chat panel. So without further ado, let's get started on the questions. So the first question we have today for Yair is, what about throughput? How can I perform migration in case I consume millions of events per second on my side?
Yeah, so throughput is again, and throughput is usually the limiting factor would usually be network. And when consuming millions of events per second, what we usually recommend, again, is to start small. And Alooma currently can handle that scale. In terms of how do we move all of this data over, all cloud providers have transfer services that are able to move with very, very high throughput, very large amounts of data. And Amazon actually took it to the extreme when they send an 18-wheeler to your data warehouse in order to transfer the existing bulk of data. Usually when ingesting millions of events per second, these events are coming from an external source. These events are coming from the users. They can come from a mobile application, they can come from the website. In that case, when we want to move the entire bulk over, the recommendation is to actually point those to the cloud directly. Because these events already come from externally. They come from the internet, they come from mobile devices, they come from the web. Once we point them directly to the cloud, and we have the data pipeline that can handle them, the data pipeline, again, either home-baked or using the cloud tools or Alooma that can handle that volume, it actually reduces a lot of the operational load to ingest in-house. If those events are pointing towards the on-premise data center, and then we want to move the millions of events per second, this throughput sometimes can be a network challenge continuously. So what I would recommend is just once you're ready, point those events into the cloud directly.
Okay, great. The second question we have is, do you also help in migrating on-premise tools like Jira and Confluence, etc.? So these look like Atlassian tools to AWS.
Yeah. So if the question is, do we deploy the tools themselves on the cloud? Then the answer is no. Alooma is a data pipeline. However, if the question pertains to moving the data, then yes. So specifically for Jira, one very common method is to use webhooks, which basically send an event every time something changes. And this is used by our customers as well. But yes, we help moving the data from many different on-premise tools, including Jira, into AWS.
All right, next question is, what types of transformations exist? Do they include pivots?
Yeah, so in terms of transformations, basically anything that can be written in Python can be performed on the stream. And even if that requires state, so for example, creating sessions or building transformation that require relating from one event to the other event, then yes, they can definitely be built on top of Alooma on the stream. And again, in terms of pivot, it's basically a free Python. We can import packages, things that are required to perform those, and we have access to state. So anything that you can code in Python can be considered as a transformation.
All right, next question is, in your experience, how long does it typically take to complete a migration procedure?
That really depends. This is actually a very good question. One of the first questions we get from all of our customers is, how long is it going to take? The answer usually is around the complexity. So how much business logic do we have to transfer, or is it only a simple pipe? And then the other is how much data is involved, especially for the initial sync, for migrating the data that currently exists. It can take any time between days and weeks for one project, or let's say we want to migrate a specific Oracle data warehouse to the cloud. But it does really depend on the business logic and how much data there is. It can be shorter than that or longer than that.
All right, great. Another question is, how would you compare Alooma to MS SSIS, Microsoft in this case, other than what is supported in terms of outputs?
Yeah, I would say that a big, maybe something that is in common to SSIS, or Oracle Data Integration, Informatica, all of what I would call traditional or incumbent data integration tools, is two things. One, they were not built for the cloud. They were not built to support cloud integrations, both in terms of data sources and in terms of a data warehouse. The other thing is that they tend to work in batches. So the data ingestion operation is usually in frequency, every hour, every 2 hours, every day, every 12 hours. Alooma was built for the cloud, and the focus of Alooma is on cloud data warehouses and both on-prem and cloud data sources, actually. And the other thing is Alooma was built for real time. So anything that can be ported over in real time or near real time is being ported over in that fashion by Alooma.
Okay, next question we have is there a command line interface or API we'd like to invoke from Airflow?
Yeah, so Alooma is fully API-based. There is an open source Python API wrapper that wraps all of the API calls. All of the API calls are REST-based, and there is a Python wrapper. There is not one thing that can be done from the UI that cannot be done from the API, and actually the API extends the UI a little bit. Airflow is a very common use case of invoking tasks in Alooma from Airflow, adding data sources, creating scheduled queries, etc.
Okay, this is following up from the earlier question about throughput. So the question is, he mentions, I assume data will be transferred at least twice to your middleware service and secondary to data warehouse. Please correct me if I'm wrong. So in case of massive data transfer, I'd better transfer data by myself. And then following that, what other benefits can I find except data transformation, connectors, and enrichment?
Yeah, I will start with the benefit. I think the main benefit, in addition to what you described in the question, is security. Because again, if you set up your own message transport service like Kafka, then the access, it's much harder to control access in the data governance around the data itself. In terms of having the data transported twice, this is not necessarily true. Alooma has endpoints, and again, this is usually comes at a later stage of using Alooma. But usually after there is a deep integration, you can point the data source directly to Alooma endpoint, and they will make their way directly to the Alooma message queue. And again, Alooma is also using Kafka, but is wrapping it as a service, taking a lot of the operational load of the load balancing and writing the messages exactly once and handling the transactional states to when moving data over, handling failures, etc. And Alooma even has SDKs, and again, some of our bigger customers are even using them, that you can put directly in the application, so in the iOS or Android or the website itself. So I would say that it's definitely you don't have to transport the data twice in the optimal use case. Normally, this is usually not the first thing that someone would implement. So normally, the first thing would not be to put the Alooma SDK inside their iOS application and start sending millions of events per second into Alooma. But that's definitely a very viable option.
Okay, the next question is, what are the most likely errors when migrating from Oracle? How can we prevent them?
Yeah, so the most likely errors are around the Oracle log format and the Oracle table map. So the way that Oracle writes the transaction log is very complex. Sometimes we might even think it was purposely complex. And what we usually do is we ask Oracle to read the transaction log, and this process can sometimes be challenging, especially in the environment of frequent DDL changes and frequent table schema changes. When implementing this in-house, you would usually either need to use an Oracle-specific license software like Oracle Golden Gate that already knows how to handle with those, or reverse engineer the format yourself and build it. Again, and when using a tool like Alooma, then of course we have invested a lot of the effort around being able to bypass these issues with Oracle log formats, etc.
Okay, great. Looks like the final question will be, what is the pricing model of Alooma?
My favorite question. So Alooma pricing model is mostly based on event volume. So it's both the number of integration and event volume, but in the high volumes, it's mostly event volume. Of course, the cost decreases on a per event basis as the event volume increases. And in terms of how much it costs, it really varies according to the volume. It can be anywhere from $2,000 or $3,000 a month all the way up for bigger customers to the 10,000 and 20,000 and even more per month.
Okay, great. That was the last question. So on behalf of Yair and Alooma, the Alooma team, we want to thank everyone on the line for joining us today. We hope everyone enjoyed the discussion as much as we did, and we look forward to today's recording and presentation in your email. And stay tuned for our upcoming and future webinars. Have a great day, everyone. Thank you very much. Bye.
Thank you.